Okay, let us start. See, do you know this Anunoy Kumar? Anyone?
No, sir, don't allow.
Deny.
Sir, fake ID, sir. Fake ID.
See, everyone must enter with their college names. Okay, whatever name is given in the college, you should enter with that name. Otherwise, your attendance and other things will not be will not be will not be considered. Okay, you must enter with your own name. Okay. Anyway, let us start. See, till now we were discussing about basics of structural engineering, right? So, introduction to structural engineering or structural analysis. So, I think now you have got some fair idea about what is structural analysis and what actually is being done using structural analysis. Now we will be now getting little more detail into it, and topic by topic we'll be discussing different things. I think Ankita Som madam has already started discussion about your structural determinacy and indeterminacy, and you have already got some idea about determinacy and indeterminacy. Now today we'll start our discussion on influence line or influence line diagram. Okay, so you see this influence line diagram. Before we get into the details of this influence line, what is influence line and why is it required, and how to find out influence line, let us start first with some basic understanding about why do we require influence line, and what is the basic difference between a bending moment shear force diagram and influence line diagram. Let us try to first understand it, then we will get into the detail about what is influence line and other things. Okay, now see, just I have just drawn two figures in this small Word document. Everyone can see it, this small Word document, everyone can see. Yeah, so see, what is this I have drawn? Can anyone tell? This is a simple supported beam, right?
BMD diagram.
Yes, this is a simple supported beam, and you see there is a point load on this simple supported beam, isn't it? So see, this point load, when it is acting on this beam, you see the bending moment diagram will be just looking like this. It's a triangular diagram, and your SFD diagram, your shear force diagram will be looking something like this. Two rectangular parts, one side is positive and another side is negative. And you notice, you observe one thing here, that when this load is put over here, that means this is a fixed load, that is a static kind of load, and when the load is just put at this position on this beam, the shape of the bending moment diagram will be always triangular like this, and you see the peak of the bending moment or the peak of the triangle will be just bottom of the load. Exactly the same way, if you notice the shear force diagram, then you see at this point there will be some positive shear force, and then it will be constant from this, and as this load is acting over here, there will be some drop, and this will go down, and then again it will be straight line because there is no change in load over here, and then it will be just getting joined over here. So there will be some positive shear force and there will be some negative shear force, and you see just at the bottom of the load there is some amount of positive shear force and there is some amount of negative shear force. Now you see, this is actually your bending moment and shear force diagram. Now you observe one thing, just I will try to explain it. See, this is little difficult to explain in this Word document and something, because if it is quite easier to explain it in a blackboard with chalk, but I will just try to explain what is influence line from this diagram. You see, This is bending moment and shear force diagram. You see the fixed load is acting over here. Now you see, suppose this load is being changed, the position of this load is being changed from here to here. It is being moving. You see the load is moving, can you observe it? The load is moving like this. Now see, if the load is, after some movement, the load is, let's say, comes over here. So what will happen to this bending moment diagram? Can anyone tell? Will it remain same?
Sir, BMD and both are changes, sir.
It will be changing. What change it will happen? Can anyone explain?
Sir, load will change from, sir, mid to.
So what the shape of the bending moment diagram will change, right? The shape of
Yes,
the bending
sir.
moment diagram will change, and you see this bending moment diagram will something will become
ट्रायंगुलर
like,
शेप हो जाएगा सर ये.
it will be also triangular, it will be also triangular, and you see the triangle, the peak point of the triangle will be here, right? Just at the bottom of the load, right? Will it not be? Is it okay? It will be looking like this or something different? Can anyone tell? It will be
Sir,
looking
same, sir.
same bending moment diagram, right? So triangular bending moment diagram, but you see in the previous case, where was the peak of this bending moment diagram? It was somewhere here, right? Just bottom of the load, isn't it? Is it clear or not?
Yes, sir, clear, sir.
Yes.
Yes, sir.
Now you see, suppose I change the position of this load from here to here, what will happen? We will come to shear force later. What will happen to this? What will happen to this bending moment diagram?
Sir, it shift towards right.
Yes, it will again shift, right? So how it will shift? It will shift like this, right? It will shift something
Yes, sir.
like this, and then it will become something like this. Okay? It will become something like this. Is it clear? So you see what is happening, but this plus sign will remain together throughout this movement of this load over the beam. You notice that this bending moment diagram will always remain positive. Is it or not? Or it will become somewhere negative? It will always remain positive. So what actually is happening, you have observed? What actually is happening, you observe? See, because of the fixed load, when this load is fixed at this position, you will get a typical shape of bending moment diagram. But when you observe that when this load is moving like this, you see for every position of this load, your bending moment diagram will change, right? Your bending moment diagram will change. If the load is moving from this end to this end, you see for every position of the load, your bending moment diagram will change. Is it or not? When the load is here, there is some other shape of bending moment diagram. When the load is here, you will get some other shape of bending moment diagram. When the load is here, you will get some other shape of the bending moment diagram. When it will come here, you will get different. When it will come here, you will get different. When it will come here, you will get different. When the load is going out of this beam, there is no bending. There is no bending moment for the beam. So you see, this is actually the concept of influence line. So you see, influence line will be actually dealing with the concept of this moving or rolling kind of loads. So you see, if you want to find out the bending moment diagram, let's say if you want to find out bending moment diagram at a particular position, let's say if you want to find out bending moment diagram at this position, at a particular position, if you take a particular position over here, let's say I name this as point C. Suppose I name it as point C. So you see, if I call this as point C, then at this point C, if you want to find out because of this movement of this load from over the beam, if this load is moving, then what will be the bending moment at this point C? Because of the movement of this load over the beam. That means when the load is here, what will be the bending moment at C? When the load is here, what will be the bending moment at C? When the load is here, what will be the bending moment at C? When the load is here, what will be the bending moment at C? So if you go on, carry on movement of this load, and if you can find out what will be the bending moment at C, what will be the bending moment at C, the diagram actually you will be getting, that is actually will be called as this Abhishek Kumar, this he's from the class. Hello,
Don't know, sir.
don't know.
Sir, he is from our class, but
Huh.
some problem has been happened, sir, with him.
Problem?
Problem हो सकता है. Yes, sir, कुछ problem हो सकता है, sir.
No, he has now entered. He has now entered. I think he has entered. Okay. Anyway, forget. So have you got this? Have you got this? So what I am trying to explain here? You see, with the movement of this load, for a particular point C on this beam, if you want to find out the bending moment diagram, then that diagram will be called as influence line diagram. That means, suppose this load is moving from here to here to here to here to here to here, and for every position of this load, if you want to find out how much will be the bending moment at C, and if you can represent it with some kind of diagram, that diagram will be called as influence line diagram. Have you understood? Now this will be exactly same in case of the shear force diagram also. Let's say when the load is placed over here, see, the shear force diagram will look like this. But when just this load will be moving to here, what will be the shear force diagram? Can anyone tell?
It got the at least, sir, midpoint, sir.
Yes, so it will just move like this, right? It will just move like this, and this will be becoming like this, and this will be reducing something to this, and it will be added, sorry, this will be little bit down, this will be little bit down over here, and this will be rectangular, something like this. Okay, so it will be looking like this. So positive and negative will remain same, but you see the shape of the shear force diagram has changed, isn't it? The shape of the shear force diagram has changed. So you see, because of this, again this movement of this load at different position, if you move the load, see, by moving this load, when this load will come over here, then you see again the shear force diagram will be changing, and the shape of the shear force diagram will become something like this, where this negative part will be becoming over here, this negative one will be coming over here, and this portion will remain as positive. So you see, the positive negative part of the shear force diagram is remaining same. So some portion is positive, some portion is negative. However, you see the shape of the shear force diagrams are changing. So how do you take care about this moving load, and how do you find out the shear force at a particular point C, when this load is moving throughout this beam, at different position of this load, how do you find out what will be the shear force at this point C? If you want to find out such kind of thing, then what you have to do? You will have to draw multiple bending moment diagram. Then how many bending moment diagram will you draw? How many shear force diagram will you draw? So to avoid such thing, there is a concept in structural analysis, and that concept of finding out bending moment, shear force, deflection or reactions. So these are the things we have discussed. These are the things actually we need to find out using any structural analysis process. And if we want to find out deflection, bending moment, shear force, reactions at a particular point in a structure or structural element because of the moving load or because of the rolling load over the structure, then the concept through which we should be able to get it directly, that is actually called influence line. Okay. So now with this basic understanding, let us move to our presentation, and I will try to explain you step by step the process of finding out influence line diagram. So you see the influence line, the first slide, if you notice, the first slide, if you observe, see the influence line, when you see, so shear or moment diagram. So ideally you have observed it from the Word document, whatever I have shown you, that shear and moment diagrams, what does it represent? These actually representing the effect of fixed loads. Fixed load means the load is static at its position. So dead or fixed load. So if you want to find out because of the fixed position of a load, so if you want to find out because of this fixed position of this load, what is the bending moment, what is the shear force throughout the different position of the beam, then you can get it through this shear force or bending moment diagram. So through that you should be able to find out the bending moment and shear force diagram. Okay. So basically if you want to find out the shear force or bending moment diagram, then you see what are you actually getting. You are getting the effect of the dead or fixed load at all points. This is very important. You see, at all points. See, when this load is over here, then you see because of this position of this load at all points of the beam, here, here. So at all points of the beam, what is the bending moment, that you can find out using this bending moment diagram. Exactly the same way, at all points of the beam, what will be the shear force along the member, you will be able to find out using along this beam. You should be able to get it using this shear force diagram. Okay. So if you want to just go ahead, and if you want to understand the concept of influence line diagram, then you see, so what actually you will have to find out using influence line. So if a structure, now you see, if a structure is subjected to a live or moving load, so if a structure is subjected to a live or moving load, then the variation of shear and bending moment, the variation, this is very important point. So if you see, when you are subjecting the structure to a live or moving load, so see, when this load is moving, that means it is coming outside from this, and then it is entering this beam, and it is just moving like this, and it is going out of the beam. So when this kind of moving load is going over this beam, then if you want to find out the variation of shear and bending moment, so variation of shear and bending moment, so what is the variation? Now you see, I have shown you the variation. See what happened in this structure. See, when this load was here, then you see the bending moment diagram will look like this. So at point C, how much will be the bending moment? At point C, you see the bending moment, there is the arrow. See, when the load is over here at the point C, how much will be the bending moment? The bending moment will be this much, right? The bending moment will be this much. However, you see, when this load will be coming to this point, then how much will be the bending moment at C? You see, the bending moment at C will be somehow, so see, the ordinate of bending moment will change, right? The distance of the bending moment, the amount of bending moment will change. When this load will come over here, then what will be the bending moment at C? The bending moment at C will become something like this. Sorry. So you see, the ordinate of bending moments are changing because of this movement of the load, and that is what is being described using the influence line diagram. So if a structure is subjected to a live or moving load, the variation of shear and bending moment, that will be best described using basically the influence line diagram. So an influence line diagram, thus what it will represent? It will basically represent the variation. So this variation point is very important. You see, at a particular point you want to find out the variation of the shear force, reaction, moment or deflection. So at a specified point in the structure or a specified point in the member, if you want to find out, because of the movement of the load, what is the variation of reaction, shear, moment, deflection in a structural element, then the same can be described using influence line. And you should remember here, whenever we will be finding out an influence line diagram, at that time we will be basically concentrating or focusing using a concentrated force. So whenever you will be developing your influence line diagram, you will be always developing with a point load or a concentrated load. So while constructing an influence line diagram, you must be moving a point load or a concentrated load over the beam or over the member of the structure. Now if you want to find out the influence for the uniformly distributed load or multiple point load or multiple or uniformly varying load, then how it can be done using the influence line diagram, we will be explaining it later. But you must remember, while constructing an influence line diagram, you must be always concentrating on
बहुत अच्छे टीचर हैं सर.
So basically, if you notice that so if you notice that if you are basically finding out, if you want to find out influence line diagram, in such case what you will have to do, you will have to use a concentrated force. That's it, very important. Okay, so while finding out an influence line diagram, you will be moving a concentrated load over the member, and because of the movement of the concentrated force over the member, what you will have to do, you will have to find out how the shear force, bending moment, reaction or deflections are varying at a specified or particular point. Okay, so you see from the influence line diagram, from the influence line diagram, thus one can tell what we can say. We can say at a glance, if you just see the influence line diagram, at a glance you should be able to say where the moving load should be placed. So the position of the load, where the load should be placed on the structure, so that the light load creates the greatest influence at a specified point. So where the moving load should be placed on the structure, so that it creates the greatest influence at a specified point. Okay. So if you get the influence line diagram for any member, then from the member influence line diagram you should be able to find out very easily that when a load will be moving over that member, then at what position of that moving load, at a particular position, the greatest influence because of that load will come. So to explain it in a very easy way, let us again go back to this document. Let's say, see, when this load, let's say this load, when it is moving, let's say this load is coming and entering this beam from here. So when the load is over here, you see the BMD will be a straight line, because there will not be any bending moment. But when this load will be coming to this point, you see your bending moment diagram will little bit change, and this point, this top point will be coming over here, right? So at this point, you see at C there will be some bending moment. So you notice when this load will be coming to this C, then only this bending moment at this point C will be maximum. So if you can plot a correct influence line diagram, then from that diagram you should be able to find out that when this load will be reaching C, so at a particular specified position C, when the load will be reaching C, then only the bending moment diagram will become maximum. Okay. So with this conceptual understanding, see, this kind of disturbances are very much happening. Okay. Who is this Abhishek Kumar? He is coming and going, I see. Abhishek Kumar. Is anyone there in the class named Abhishek Kumar?
Sir, roll number 94, sir.
Roll number.
It's a fake ID.
But 94 is entering the class or not? He is coming to the class?
Don't know, sir.
ये उसका फेक आईडी है सर.
But with this fake ID, how is entering?
शायद उसका लगता है फेक आईडी है.
No, with this ID, how is entering the class?
Sir,
I have not
is you, sir, मेल सर किसका सर? मेल इसमें सर मेल जो कर रहा है सर, किस मेल से ज्वाइन हो रहा है सर? ये
वो तो समझ में नहीं आ रहा है. That we cannot see.
अनुज, अनुज चेक करो तो कौन सा मेल से ये इंटर कर रहा है.
Can we
वो
check?
सर आप एडमिट किए थे ना, अभिषेक कुमार को एडमिट किए थे.
नहीं किए थे एडमिट, नहीं किए सर.
I didn't admit him.
कहाँ किया एडमिट सर?
No, I didn't admit. See, I only admitted Liton. I didn't admit that Abhishek Kumar. And then another one ID also tried to enter. I didn't admit.
सर फर्स्ट में किए थे सर आप कर दिए थे
सर. आप एडमिट कर दिए थे शायद गलती से सर.
यस सर, आप एडमिट एक बार कर दिए थे.
Okay.
आप बोले थे कि छोड़ो एडमिट कर दिए.
Okay. So maybe, but he has left it. So again he is getting permission to admit without getting
और अगर एडमिट कर दीजिएगा उसके बाद
डायरेक्ट
परमिशन
एडमिट हो
नहीं
जाएगा.
हाँ?
अब परमिशन नहीं चाहिए. अब परमिशन नहीं चाहिए होगा सर.
But next
डायरेक्ट आ
meeting,
जाएगा.
in the next meeting,
नो सर.
next
वो
meeting he will
एडमिट
again
मांगेगा.
he will have to admit, right? He will have to again get it, right?
यस, रिक्वेस्ट करेगा तभी रिक्वेस्ट करेगा, आप एडमिट कीजिएगा तभी.
No, I will see. Then from next meeting we are not going to admit anyone. That is the decision I am taking. Okay, I will not admit anyone. So who is this myself Ankit? Who is this myself Ankit?
अंकित कुमार सर 91
He is there.
92 है ये.
He is there in the class.
92 roll number.
He is there in the class. Myself Ankit.
Yes sir,
Yes,
yes,
sir.
yes.
See, you please come with your own names. It's very difficult, right? And Anuj Kumar, two common names are there, right? Ankit,
यस सर
Ankit, myself Ankit.
Yes sir, 89 and 90 sir.
3 नाम है
89.
सेम वाला
Which, what is your roll number?
92
92. So why is your name myself Ankit or something else?
क्या सर
What is your name? Your name is myself Ankit.
नहीं सर 3 नाम है इसीलिए अलग
So what you do, that is what I am saying. You just write Ankit roll number, Ankit 92. That will be better, I think. Then Anuj, 2 Anuj are there. You write Anuj 91, Anuj 92, like that. So it will be very difficult.
Yes,
It will
sir.
be easy to understand. When I will be, see, I will be able to take the attendance using the Google attendance collector. Okay, just write your name, and beside that, if common names are there, if common names are not there, you just enter with your own name. But if common names are there, like 2 Anuj Kumars are there, 2 Ankit Kumars are there, so the common names you please enter with your name and your roll number, just last 2 digits of your roll number. You write Ankit 92. That's all. I will be able to understand. Okay. From the next class, you please do it.
ओके
Okay. Now you see. So with this, let us go to the next slide. Now you see, this one I have explained already. So you see, if it is a live analysis of forces due to live loads. So if you want to, if a load is moving, let's say if a load is moving, so you see how the shear force diagram will change. I have shown you, right? In the what document also I have shown. So see, when this load is over here, your shear force diagram will like this. When the load is over here, your shear force diagram will look like this. And you see, you observe that your shear forces, this V1 and V2, because of this change in position of the load, you see, for a particular position, see, because of this change in position of the load, you see, when this load is pointing, when this load is over here, then you see the shear force at this point P is V1. But when this load has moved from this position to this position, you see the shear force at this point will become V2. So this change in shear force, actually if you want to find out, or the variation of the shear force at point P because of the movement of this load throughout the beam, if you want to see, then you should be able to find out using the influence line diagram. Now the next thing is, so question now is, this thing already we have explained. So where should a structural engineer place the live load on the structure? See, you have already understood that if you put a dead load or a fixed load on a structure, then you should be able to find out the bending moment and shear force of that structural element very easily. However, where will you place, as a structural engineer, where will you place the live load on the structure? So, where will you place as a structural engineer the live load on the structure, so that it will create the greatest influence at a specified point? Where will you place, as a structural engineer, the live load on the structure? Live load means the moving load on the structure, to find out at what position of that load that at a particular point will be creating the greatest influence. Okay. So if you want to find out that greatest influence at a specified point because of the moving load, then such can be only determined using influence lines. And these influence lines ideally then will give you the variation of reaction. So this is very important. Variation of reaction, shear, moment or deflection at a specified point due to a concentrated force moving on the member. So I think now you have got the concept of influence line. So with this conceptual understanding, let us move little forward and let us move to the next slide. So you see this. So what actually you are going to get? So the magnitude of the associated reaction, shear, moment or deflection. So whatever the shear force, whatever the reaction, whatever the moment or whatever the deflection, there will be a comma. So reaction, shear, moment or deflection at a particular point, if you want to calculate, then what you can use? You can directly use the influence line diagram, and the ordinate of the influence line diagram is going to give you the magnitude of the associated reaction, shear, moment or deflection. So you should understand it very clearly that like the bending moment, shear force, deflection diagrams, influence line diagrams also need to be constructed separately for particular variables. That means the things which you need to find out. So if you want to find out the influence of shear, then what you will have to do? You will have to find out the influence line diagram for the shear force. Then you will have to, if you want to find out the effect of bending moment, then you will have to find out the influence line diagram for bending moment. If you want to find out the effect of deflection, then you will have to find out the influence line diagram for deflection. If you want to find out reactions in the structure, in the support, at the support, then you will have to find out the influence line diagram for the reaction. And from those influence line diagrams, so from those different influence line diagrams,
America. Nope.
from those different influence line diagrams, you should be able to find out, from the ordinate of the influence line diagram, you should be able to find out at different points, at a particular point, because of the position of the load at different points, what will be the value of shear force, bending moment, deflection, reaction, etc. So to construct, now if you want to construct influence line diagram, we will be explaining it through mathematical examples, but before that you just understand the concept. So if you want to construct the influence line, so for what you will be constructing influence line? You will be constructing the influence line for any function. Any function means the things which you want to know from your structural analysis. That means you want to know reaction, moment, shear, deflection. That is what we have discussed, right, while introduction to structural analysis. So if you want to find out at a particular specific point in a member for any function, then what you will have to do? You choose the moving force to have a dimensionless magnitude of unity. So this point is very important. So if you want to construct any influence line diagram for any function, that means if you want to construct influence line diagram for shear force, or it bending moment, or it may be reaction, or it may be deflection, whatever may be the case, for whatever reason for whatever case you want to find out the influence line or you want to construct the influence line diagram, what you will have to do, you will have to move the unit load over the member, and that unit load should be a dimensionless quantity. That means if you go back here, when we are talking about this load, so this load always should be a unit. So the value of this load while constructing the influence line diagram, you should take this value of this load as 1, and you need not to consider any unit for it. That means you need not to consider whether the load is in kilonewton, whether the load is in pound, whether the load is in quintal, whether the load is in kg. You need not to think about any unit. Okay. So without considering any unit, so basically what you will have to do while constructing influence line diagram, when you will be moving this load throughout this structure, you must consider this load as a unit load, and this unit load should be a dimensionless number. So this is very, very important point. So you need not to consider any other thing.
Nobody does it better.
This Abhishek Kumar is only disturbing, I understand. Can you see Anuj, this Abhishek Kumar?
सर अभिषेक नहीं है सर, उसको कॉल करके हम अभी पूछे।
हाँ. But this Abhishek Kumar,
नहीं है सर।
someone is again and again entering and then disturbing the class. That is what I am seeing. But someone is muting. I am seeing this Dibakar Chakraborty muted Abhishek Kumar. It is being observed. So how do you able to mute him? I cannot see him here. Anyway, forget it. Forget about it. Let's go ahead. See, this type of disturbances are very, very annoying actually, because every class I think it is happening. Anyway, see, the influence line thus can be constructed. This line is very important. Thus influence line can be constructed. How do you construct? You just place unit load. Where will you place it? You just place the unit load, and what kind of unit load you will have to place? You will have to place an unit load with dimensionless unity. Okay. So dimensionless unit load you put, and where will you put? You put at a variable position x, because you see you will have to put it as a variable position x. Sometimes this unit load will be here, sometimes this unit load will be here, sometimes this unit load will be here, sometimes this unit load will be here. So you will have to put it this unit load at a variable position. That means from any one end you will have to put the load at any distance. Let's say at any distance, you say at x. Are you getting? So at any distance x you will have to place this load. So if you place it at any distance, that means if x is any variable, then you see if you just reducing it, then the position of x will change, then your position of x will change. So if this load is moving over here, the variable x will change to here. So this is what is actually x will do. So this x means the influence line, thus when you will be constructing, you will have to place the unit load at a variable position. You have got it? What is variable position? So at a variable position x on the member, and then you will have to compute the different values. So what are the values you should be interested in? You will be interested in different values, right? Like your R means reaction, then V means moment, V means shear force, M means moment, and delta means deflection. So for different values, of these, this reaction, shear force, bending moment, and deflection at a particular point, if you can find out as a function of x, if you can find out the values of these, then what you will be finding out? You will be actually finding out the influence line diagram for that member. In this way, actually what you will be getting? You will be getting the equations of various line segments. See, we will be showing it later when we will be taking one or two examples. Then you will be seeing that at different position of the load, and load means this unit load of dimensionless magnitude, when you will be placing, then whatever, because of the variable position of the load, you will be getting equations, and those equations you will be noticing, those will be coming as the equation of straight lines. And thus, for the influence line diagram, ideally you will be getting various line segments, and your influence line diagram will be composed of various line segments. And when you will be able to determine the various line segments, and you will be able to plot it, then you should be able to get the final influence line diagram. Is it okay? Okay. Next. So finally, you see, after all this discussion, two or three things we have got it. The first thing is, one should be clear. So you should be clear. One should be clear means we should be clear about the understanding that what is the difference between influence line and shear force or moment diagram. So you should not get confused. You should not get yourself confused about influence lines with shear force and bending moment diagram. See, influence line diagram for bending moment you will be getting, but that is not bending moment diagram. So whenever you will be drawing an influence line diagram, it will be influence line diagram for bending moment or shear force or reaction or deflection for a particular point on a member, but it is not a bending moment diagram or shear force diagram. And from that influence line diagram, you should be able to find out the influence of the load at various position on the beam for that particular position, and what is the influence that variable load or moving load is making at a particular point, that you have to find out. Okay, and thus you should be very clear about the understanding or the difference between the influence line and shear or moment diagram. So influence line thus represent what it represents? It represents the effect of a moving load on only at a specific point. This is very important. It does not give you, unlike the bending moment shear force diagram. If you see, for a bending moment shear force diagram, what is happening, you are just getting for a fixed position of the load at different position of the beam, what is the bending moment and shear force diagram, what is the bending moment. However, in case of influence line diagram, what you are getting? You are getting the effect of the moving load. That means when the load is moving over the member, then for a particular or a specified point, because of the changed position of the load, what is the influence that load is making at that particular point on various quantities like bending moment, shear force, reaction and deflection, that you will be able to find out. Shear or moment diagrams, on the other hand, what it is representing? It is representing the effect of fixed loads at all points along the axis of the member, and this is what is the difference. So with this understanding, let us move to a small example. Today we will take a small example of finding out the influence line diagram for reaction at a particular point, at a specified point, for a simple supported beam. So let us see this example, example 1. So you see, if you want to construct the influence line, okay, see, if you are asked to construct the influence line for the vertical reaction at A of the beam, so you see, if you want to find out the influence line diagram for reaction at A, so this is a simple supported beam of 10 meter length. So your question is, you need to find out the influence line diagram for the vertical reaction at A of the beam. So if you want to find out,
सर आपको म्यूट हो गया,
कोई म्यूट कर दिया यार।
हाँ, वो अभिषेक कुमार ही किया है।
अनम्यूट कीजिए
सर,
सर,
आप म्यूट हो गए सर।
Yes, just a minute, wait, just a minute.
संजय सर चले भी गए क्या?
That Abhishek Kumar has done it. Okay.
Yes sir.
See, you can't get hold of this useless guy. I think he is the person who is disturbing the class. Are you getting?
He is disturbing all the classes, sir.
So can't you find
From
out
beginning.
this guy?
सर आप ऐसा नहीं कर सकते सर कि किसी को उसको रिमूव करने का मतलब राइट्स दे दीजिए ऐप में,
रिमूव
किसी स्टूडेंट
करने का मतलब?
क्योंकि वो आती ऑर्गेनाइज किए हैं।
Pardon?
सर आप
फिर से
ऑर्गेनाइज
बोलो
किए
ना।
ना मीटिंग, तो आप इसे आती रिमूव कर सकते हैं ऐसे, हम लोग में से कोई नहीं।
हाँ, तो I means can I see, I cannot make anyone else owner. Na, if someone else become owner, then I will be losing the ownership, I think.
यस सर, यस
यस
Yes, sir.
That is the problem. So I will not be then able to present another thing. Then someone else will have to connect, and first they will have to come always. So that is the problem. I'll check. However, I'll check if I can make someone owner, like one CR or Anuj, someone of you. If I can make you owner also, I'll try that. Okay. But you should try to find out this guy. Okay, he is disturbing all the classes. Who it can be? That is what is the question. And he is coming with the name Abhishek Kumar.
ईमेल आईडी सर उसका मिल जाता तो पता चल सकता था।
तो email ID तो नहीं मिल रहा है ना यहाँ से. You don't get email ID right from here. Are you or not? We cannot get email ID from here.
यस सर।
The problem with him is basically he is not only disturbing the class, he is just enjoying it. That is the problem. Means he is enjoying that no one can catch him. So, but he should also understand that if he is caught, then severe punishment he will get. Anyway, see, we are just losing time because of these things. Mizan Khan, deny entry. Okay, let's see. See, so suppose if you want to find out the construct the influence line for vertical reaction at A of the beam, then you see, I just given you this, I just wanted to give you this solution. See what you will have to do for finding out influence line, what I have said. Tell me, anyone can tell? What you will have to do? Hello? First step, what you will have to do? Tell me.
To find reaction, sir.
Reaction. So where you will have to find out reaction? Reaction at A, right? You will have to find out reaction at A. So to find out reaction at A, you must require a load, right? A load should be there. So see, on this beam there is no load given. So what you have said? For constructing influence line, what you will have to do? You will have to move a load of unit magnitude, right? Unit magnitude. That means load of value 1 without any unit, with a dimensionless number. You will have to move it over the beam, and for every position of the beam you need to find out. So for every this thing, for every position of the load, you will have to find out what is the reaction at A. What is the reaction at A? So to do that, what you will have to do? So you see, to find out this reaction at A, see, first if you put this load, 1 at here, first if you put this unit load over here, then what will be the reaction coming at here? Can anyone tell? How much will be the reaction at A? Hello? Suppose this unit load, you are just placing on top of the support. Then what is the value of your, what will be the value of your reaction at A? What will be the value of load at A? Can anyone say? It will be 1.
Sir, by using a moment equation, sir, we can find.
Yes, by using moment equation. So if you want to use moment equation, then what will happen? So if you want to use moment equation, then it will be, what will happen? So you will be just doing moment equation, means you will be writing R or A into the distance, right? RA into 10, right? Correct?
Yes, sir.
Then what will happen? RA into 10 and 1. Here it is 1, right? Is it or not? Load is where? Load is over here. See, you are not getting, I think. See, suppose
सर फिर से म्यूट हो गया है.
This student is,
कौन नॉनसेंस है, इतना गंदा इंसान.
हमारी
see, you are putting this load over here. Okay. So what you will get? So if you want to take moment about this, moment about B, so what will be moment about B? Reaction at A into 10. This distance is 10. What is the distance? This distance is 10. This distance is 10. So what will be the reaction? What will be the reaction at A? So if you want to find out here, so RA into 10. This load is how much? This load is 1. So RA into 10 minus, you will have to do minus 1 into how much? 1 into 10.
2.5.
No, 1 into 10, 2.5. Don't
Yes,
take
sir.
2.5. First you
Yes,
see,
sir, yes, sir.
first this one load is over here. Let's say if you are putting the load over here on
Yes,
the
sir, yes,
support.
yes, sir.
That's what I am showing here, right? So 1 into
Yeah.
10 is equal to 0. So how much it will be? RA into 10 is equal to 10. You are going to get, right? So that means RA is equal to how much? RA is going to be, so RA is going to be equal to 1, right? RA is going to
Yes,
be
sir.
equal to 1. So see, you are putting this unit load at variable positions. You are putting this unit load at variable positions.
क्या टैलेंट है वो तुम लोग के डर से तुम लोग सारा मारा चोद लोग सारा
ये यार कौन
ये यार
रुकवा के बात करो, इससे पहले बात करो।
ये जो भी है मत करो यार।
See, by mistake, I think I have given him permission. That is the problem, because otherwise he could not have disturbed, right?
Yes,
Anyway,
sir.
from next class I will not give anyone permission.
जी जिसका मेल नहीं है सबमिट मेल सर को जमा कर दो अभी दे दो।
I will not allow anyone without that this thing. Anyway, forget it. So see, अच्छा से समझने का कोशिश करो, ठीक है? देखो, ये मैं डिलीट कर देता हूँ, ये इसको डिलीट कर देता हूँ। देखो, when the load is here, then how much? RA into 10 minus 1 into 10 is equal to 0. So RA is equal to 1, right? So RA is going to be equal to 1.
क्या लगता है तेरा वो
See, I think let us stop today's class, okay? We'll discuss it in the next class. Too much disturbance. Okay, Abhishek. Abhishek
absent है sir.
Abhishek, Anuj is there?
छोड़ो तुम लोग हाँ
Anuj is there, Anuj?
Yes, yes.
यस सर।
Anuj, today let us stop here, okay? So we'll in the tomorrow's class we'll discuss about this this diagram, because today
Yes,
we
sir.
will not be able to finish also, okay? So in the next class we'll discuss, okay? We'll be going little bit slow, no problem. Okay, thank you.
थैंक यू
Thank
सर।
you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
थैंक यू
Thank
सर।
you, sir.
थैंक यू सर।